Hello grade 11s. Today we're going on to rate calculation. In other words, finding out what the interest rate was. So we've got, and this is for depreciation and your normal, compound and interest formulas and stuff like that. So I'm just going to write the formulas up here. And I'm just going to say plus minus. The plus would just be your normal simple, and then the minus would be your straight line depreciation. And then you've got the compound one. I to the power of n. Okay, where the plus is just your normal compound, and then the minus is your reducing balance. So what we're going to be doing in this section is we're going to actually be calculating what is this I value. Okay. So just a couple of things here that you guys need to get down in your book. So simple interest and straight line depreciation rate calculations are straightforward since only a linear equation needs to be solved. And this is this one over here. It's just a linear equation. Now, for a compound interest and reducing balance depreciation, it is necessary to apply the nth root to both sides of the equation. Now, what they mean by that is because we want to get this I on its own, this power over here, which is n, we need to get rid of that, and we have to take the nth root. And you'll see here with examples just now how we do that. Okay, just a couple of things to remember here. Remember to express any calculated rate as a percentage per annum, correct to the required number of decimal places, and stating the correct compounding period. All right, so if we look at example 1, they're saying here, the value of a piece of equipment depreciates from 10,000 Rand to 5,000 Rand in 4 years. What is the rate of depreciation if calculated on the straight line method? So let's have a look how we would do that. So example 1, question A. Okay, so if we go back here, they're telling us that we have a piece of equipment that depreciates from 10,000 to 5,000. So our accumulated amount is 5,000. Because remember that this is depreciation. Our principal amount would be 10,000. The interest, we don't know. That is what we're going to calculate. And then our time period is 4. Okay. And they told us here that it's a straight line method, which is this one over here. So we've got here A is equal to P, 1 minus I times N. Just substitute our values in. So we get here 5,000 is equal to 10,000. 1 minus I times 4. So the first thing I'm going to do here is I'm going to divide both sides by 10,000 because remember we want to get the I on its own. So 5,000 divided by 10,000 and we're left with a half equals 1 minus 4i. I'm going to take the minus 4i to this side and then I'm going to take the half to that side and we get 4i is equal to 1 minus a half is a half. Then to get I on its own, we divide both sides by 4 and we get I is equal to 1 over 8. Now that we have the I, we need to change it into a percent. And remember, we do that by multiplying by 100. So I would be equal to 1 over 8 times 100 will give us 12.5%. And what we need to state here at grade 11 is we need to state that this is a per annum rate. Okay. Now going on to question B. They're saying here exactly the same thing. Value of a piece of equipment depreciates from 10,000 to 5,000 in 4 years. We need to calculate the rate of depreciation if it's a reducing balance, which is this one here. Okay. So we've got A is equal to 5,000. Principal is 10,000. I, we're going to calculate, N is equal to 4. So this is your straight line. We need to now do the reducing balance, which is A is equal to P, 1 minus I to the power of N. Just substitute the values in, and we get 5,000 is equal to 10,000. 1 minus I to the power of 4. Okay, so first thing I'm going to do, divide both sides by 10,000, and we get a half is equal to 1 minus I to the power of 4. Now remember, we need to get this I on its own. So we have to get rid of that power. So I have to take the 4th root on this side and the 4th root on that side. Okay, if you do this on your calculator, you will get 0.840896 4153 equals 1 minus I. Now grade 11s, notice how I've not rounded this value off. I will only round off the final answer. Okay, so I'm going to take the I to this side to make it positive, and I'm going to take this to that side and it becomes a minus. So we have 1 minus this, and we will get 0.159 103 5847. Okay, now exactly the same as this, I need to multiply this by 100 to get it into a percent. So if I multiply it by 100, I'm going to get 15,9 and so on, and I'm going to round this off to 1 decimal place. So we get I is equal to 15,9% per annum. Please do not forget to write the per annum bit. Okay, it's as easy as that, guys. Okay, going on to the next couple of examples. So this example 2, they're saying here that 100,000 is invested in a pension fund and grows to 250,000 Rand after 10 years. What is the annual effective interest rate earned by the fund over the period? Okay, so example 2, we've got A is equal to, P is equal to, I is equal to, and N is equal to. So our accumulated amount, they invested 100,000, and what came out was 250,000. So accumulated amount is 250,000. The principal was 100,000. The interest we don't know, and the time period for this was 10 years. Okay, and because it's an investment, guys, this is going to be your compound interest formula. Okay, just substitute everything in, and we get 250,000 equals 100,000. 1 plus I to the power of 10. Divide both sides by the 100,000, and we get 5 over 2 is equal to 1 plus I to the power of 10. We need to get the I on its own, so we need to take the 10th root here. What I do to this side, I must do to this side here. Okay. If you put this on the calculator, you will get 1,0959 58226 equals 1 plus I. I'm going to take the 1 to this side, becomes a minus, so we get I is equal to 0,095958222639. Convert this into a percentage, and then we're going to round off. So multiply by 100, and we get 95, and that's going to change that to 6. So it's 996. I is equal to 9.6% per annum. But now, this is a compound interest formula. So we need to now specify what is the compound period. You know, is it daily? Is it monthly? So we just have to say here, compounded annually. Okay, and we know it's going to be annually because this was in years. All right, so if we look at example 3 now, calculate the nominal interest rate compounded monthly that would double an amount of money in 7 years. Okay, so they haven't given us any exact values, but I know that things are going to double. It doesn't make a difference what our investment was. We just want it to double. So what was our investment? Well, make it X. It's whatever it wants to be. But the main thing is that our final amount is doubled our invested amount. Okay. The interest rate, we don't know, and it's over 7 years. But here comes the trick, grade 11s. They've told us that it's compounded monthly. So this is in years, so I need to multiply this by 12 because there's 12 months in the year. So this gives us 84. Okay, so our compound interest formula is A is equal to P, 1 plus I to the power of N. Now, what I want you to keep in mind, guys, is because I multiplied this one by 12, remember we have to divide this one by 12. It'll come out in the end, and I'll show you how we deal with that. Okay, so here our accumulated amount is 2x equals, our principal is x, 1 plus I to the power of 84. Divide both sides by x, and we're left with 2 is equal to 1 plus I to the power of 84. We need to get the I on its own, so I need to take the 84th root. If I do that to this side, I must do it to this side. Okay. Do this on the calculator, and you get 1,008,285,892 equals 1 plus I. Take the 1 to that side, it becomes a negative, and you're left with that I is equal to 0,008,285,892. So we're at this stage now, and I need to now multiply this by 100 to get it into a percent. Okay, and if we multiply this by 100, we'll get I is equal to 0,828,589,1695. Okay, now a lot of people would just stop there, but remember that this is in a monthly rate. We want to convert it into an annual rate, okay? And if we times this by 12, remember we divided this one by 12. I need to do the opposite now because we divided whatever it was by 12 to get this. So I need to now multiply this by 12 to get it into an annual rate, because remember that this is a monthly rate. So if you multiply that on the calculator by 12 and round off to 1 decimal place, you'll get I is equal to 9.9% per annum. That's your per annum rate. This is your monthly rate. Okay, guys. And what you guys can do for me now is you can do exercise 12.5, numbers 2, 3, 4, 6, and 7. Thanks, guys.